So we hear it all the time, right? AI models are getting smarter, they're getting faster, more capable every single day. But how do we actually know they're getting better? I mean, really know. How do we test the AI that's supposed to be testing all the other AIs? Well, that's exactly the challenge we're going to unpack today.
And this, right here, this is the multi-billion-dollar question at the very heart of AI development. If you want to make AI better, you absolutely need a reliable way to teach it the difference between a great answer and a terrible one. But what happens when the grading system itself is kind of broken? For a while now, the solution has been something called a reward model. Just think of it like an AI tutor. It's been trained on tons and tons of data showing what answers humans prefer. This one's better than that one. And its whole job is to score any new response, guiding the student AI to get better and better. Sounds simple enough, right, isn't it? Well, not so fast. Yeah, it turns out that the very exams we were using to grade these AI tutors, they really weren't up to the task at all.
So here's the problem in a nutshell. The old benchmarks, the old tests, they were basically like an open book exam where all the answers were already highlighted. They were way too simple, and sometimes they even just reused questions from other tests. What that meant was an AI tutor could totally ace the exam, but still be a pretty awful teacher out in the real world.
So to fix this, a bunch of researchers from places like the Allen Institute for AI got together and built a new, much harder final exam for these AI tutors. And they called it REWARDBENCH 2.
Okay, now what's so cool about this slide is you can see just how big the jump in difficulty was. The old tests, they were often just a simple A or B choice. But REWARDBENCH 2, it uses what's called a best of 4 format. That means one right answer is hiding among 3 other really convincing wrong answers. Just by doing that, the odds of a random guess getting it right plummet from 50% all the way down to 25%. It forces the AI tutor to actually know what it's talking about.
And the effect? Whoa, it was dramatic. On average, even the best of the best AI reward models scored about 20 points lower on this new, tougher test. And that's not because the models suddenly got worse, it's because the test got way better at finding their weak spots.
And this slide gives you a little taste of just how broad the challenge was. This new test covers 6 really critical areas. We're not just talking about getting facts right. It's about following super specific instructions, solving tricky math problems, being safe, and even knowing when 2 totally different answers are actually equally good. All right, so we've got a much harder test that's giving us a more realistic score. But what did we actually learn from all this? Because this is where things get really fascinating.
Like we saw, scores dropped big time, right across the board. This chart here just kind of gives you a visual of that reality check. An AI that might have scored a solid 85 on the old easy test is now looking more like a 65 on the new one. And that gives researchers a much clearer picture of where they need to improve.
And for some of the simpler things, the logic held up just fine. If all you wanted an AI to do was pick the best response out of a few options, something called best-of-n sampling, then yeah, the AI tutor with the highest score on REWARDBENCH 2 was in fact the best one for the job. But, and this is a huge but, that's not the whole story. Not even close. When the researchers looked at the most advanced, most sophisticated training methods, like RLHF, the results just completely flipped conventional wisdom on its head. And what they found was a kind of surprising family secret.
Yeah, it turns out that when you get into the really advanced stuff, there's this hidden family dynamic that's secretly at play.
Okay, this right here is the big reveal. For the really complex training, the best AI tutor isn't always the one with the highest score on the test. Nope, it's the one that comes from the same model family as the AI student is trying to teach. So if the tutor and the student share the same architectural DNA, so to speak, performance goes up. But if you pair that student with a tutor from a different family, even if that tutor has a higher test score, performance can actually go down a lot. So what this really tells us is that context is absolutely everything. It's kind of like discovering that the best tutor for a high school kid isn't the Nobel Prize-winning professor, but their older sibling who just took the same class and just gets how they think. That shared background, that relationship, it turns out it matters more than some raw score on a leaderboard. And hey, don't just take my word for it. The researchers themselves put it perfectly. They state it clear as day. Simply taking the highest scoring reward model on a benchmark will not ensure a good post-RLHF model. I mean, that finding is a huge deal. It means you can't just look at a list, pick number 1, and assume you're going to get the best results. You have to think about the whole system. Which leaves us with this final, really critical question. If one single number on a test doesn't tell the whole story, then how should we really be measuring intelligence in these systems? And as AI gets more and more woven into our world, you have to wonder, what other family secrets and hidden relationships are just waiting for us to find them?